number 16 from the printed review that I gave you. And this one, if you look at it, it looks like kind of a product quotient rule combo problem, right? Personally, what I would do with this one is I would just multiply the top out first so that I just have to do quotient rule. So x times x to the 1/2 is x to the 3/2 over 3x plus 5, and now it's a much easier problem, right? So now if we do f prime of x, we have quotient rule. So the derivative of the top is 3x to the 1/2 times the bottom minus the top times the derivative of the bottom all over the bottom squared, right? So any questions on the initial derivative? Yes, JP?
Why is it 3 over 2? For the very top.
Oh, right here?
Yeah.
Oh, because this is x to the first, and this is x to the 1/2, and when you're multiplying, you add your exponents, right? Okay. Any other questions before we simplify? Yeah.
So you did the quotient, the product rule on top and then like simplify it?
I didn't do product rule at all.
Okay.
I just went ahead and rewrote my function first
okay.
before taking the derivative so that I didn't have to do product rule.
Okay.
Yeah. All right. So now, if we multiply this in here, we get 9x to the 3/2 plus 15x to the 1/2 minus 6x to the 3/2 all over our denominator. And then just combining like terms. So you get 3x to the 3/2 plus 15x to the 1/2. Now, how do you know when to stop simplifying? Well, personally, if I was doing this problem, I would probably stop here, but the directions on the sheet said that the answer had to be in fully factored simplified form. So because of that, we have to factor out the GCF, just because we have to follow directions. So we have to factor out 3x to the 1/2 out of each term. When you divide, you subtract the exponents, so 3/2 minus 1/2. So we're left with just x on this guy, and then plus 5 for that guy, over 3x plus 5 squared. So that was a fairly complicated one. Not every derivative on your test is going to be that complicated, but there might be one.
Why wouldn't the you factor out the 3x to the 1/2? Would the x become like x to the 3rd? Or?
No, you're not. When you divide with exponents, if I have x to the 3/2 divided by x to the 1/2, yeah, you have to subtract the exponents. You're not dividing the exponents. Good. Other questions? Okay. Question? Yes. Sure, we can do 19. All right. Any other questions on 16 before I erase it? Okay. All right. So, okay, 19 is this guy right in the middle. Okay. Fix the camera. Okay. So here's 19. And this is just, is this just going to find the derivative? Yes. Okay. So this is a product rule. In order to do product rule though, first we've got to rewrite our function with exponents instead of radicals. So we have u minus 1. What is this with an exponent? 1/2 times 2u plus 3 to the 1/3. Very good. Alright, you cannot FOIL that out, they don't have the same exponent on them, right? You just have to leave them. So to find h prime of u, this is just standard product rule. Derivative of the first is 1/2 times u minus 1 to the negative 1/2 times the derivative of the argument, which is just 1, times the second term, plus the first term. Now we gotta do the derivative of this guy. So we get 1/3 times 2u plus 3 to the negative 2/3 times 2. Now we gotta simplify. Right? Simplifying is the fun part. Okay, so here we go. The 2 goes on the bottom, this goes on the bottom, this goes on the top, right? So we have a cube root of 2u plus 3 over 2 square root u minus 1. Alright, for this term, top, 3 goes to the bottom, this goes to the bottom, that goes to the top. So on top we have 2 root u minus 1 over 3 times the cube root of 2u plus 3 squared. If you had to find an LCD for this, you would have to multiply this top and bottom by that guy, and this term top and bottom by that guy. But I don't want to get into it right now because it's just time consuming and we don't need to go there. Yes, Jim?
For the first one left, the plus sign, can you explain what goes up and down?
Oh, for like to go from here to here?
Yeah, but for the other one.
Oh, for this one?
I was thinking.
Sure. Well, 2 goes on the bottom because it is on the bottom, right? This has a negative exponent, so it goes to the bottom. And this has a positive exponent, so it stays on top.
Oh, that 3's a part of the square root. Okay. I
The
missed that.
3, the 1/3 means it's a cube root. Yep. It's the negative that makes a term go to the bottom.
Okay, thank you.
For the like the 2 on the very end, isn't that part of chain rule or is that part
That is part of chain rule.
So
You kind of, here's how it worked. When you're doing, and this is a very important point. So here, this problem, you know it required a product rule, right? Because it was something times something. Okay, so we had, think of like, this is like our f and our g, right? So we did f prime g plus f. To do g prime, to do the derivative of this, the only way to do the derivative of this term is to use chain rule. So you will find yourself using chain rule within product rule or chain rule within quotient rule all the time. Yeah. Yeah, Jennifer.
so basically to be able to multiply it out and do product rule, you have to like find the derivative of that first to like do it, I guess. Is that what you're saying? Like
What I'm saying is you can't rewrite this function any simpler than this.
Okay.
There's no way to get rid of this product.
okay. So like if it's gonna have an exponent
I mean, technically you could.
have to
Technically you could
change-
sit there and find an LCD and figure out a way to do it somehow. It'd be, I don't know,
Okay.
it'd be really tricky. So, yeah, I would just do the product rule.
You mean like, what I was asking is if you see like an exponent with like for 18, you would do the chain rule.
Product rule, but you, in order to do the derivative of this term, you do chain rule, and for
Okay,
this term,
yeah,
you'd have to
that's
do
what
chain
I was
rule.
asking.
Yeah, so like 18 is a much faster one, and we're still good for camera, so let me just do setup really quickly on it. Okay, so f prime, actually why don't you guys take a sec, because I'm gonna make you guys get out paper anyway today. Take 1 second and just write the first line of the derivative of 18. Because you're gonna be doing a lot of other problems today, and might as well start now.
Mrs. Price?
Yeah.
Remember 19? Why didn't you use chain rule after the first thing you wrote? Like, why didn't you do 1/2 u minus 1 raised to the negative 1/2 times 1? Oh, you did.
It's just, I mean, times 1 is just it, so.
And then you multiply that by 1/3 2u plus 3 to the negative 2/3? Or
You gotta do product rule. derivative of the first term times the second plus the first times the derivative of the second.
Okay.
Does that make sense? So don't do derivative times derivative. That will never work. Yeah. Yeah, whenever the chain rule requires you to do times 1, I don't usually write the 1.
Okay.
Yeah. But you sure can. There's nothing wrong with it. Alright, everyone got their first line? Oh, you pressed it right. You ready? Here we go. So we have 3 times 4x squared plus 3 to the second times what?
8x.
8x, good. Times
3x minus 2 squared.
3x minus 2 squared. That's f prime g plus. Okay, can I erase this one so I can write across? Okay. Alright. Okay, plus f 4x squared plus 3 cubed g prime. So 2 times 3x minus 2 to the first times 3. How'd you guys do? Thumbs up? Good. Fantastic.
What'd you do there?
That's part of
How far?
How far would I go? You know, I would stop there personally.
Because the answer key like went on and on. And
I
on.
know, that's because it had to be written in fully factored form. So technically you're supposed to pull a GCF out of each term, right? For this worksheet, it wanted it fully factored, so you have to look at everything that's in common to both terms, write it up front, and then write what's left. But there's nothing on your test that requires anything like that, so it's not
So on a
really
test, that
necessary.
would be like all we do.
If there was a problem like this, I would be happy with this answer.
Will there be a problem like this?
Well, there will be product rule. Here's what'll happen. Personally, if I were to ask this question on a test, what I would do is say, tell me what f prime of 1 is, right?
So then you
And then you can just leave it however you want and plug in the 1, right? It's so much easier for me to do that than to have you guys simplify.
You're so much smarter than you.
Anyway, so,
Maker.
alright. Are there any questions on that one?
I said worksheet maker.
Okay. Okay, any other questions from this worksheet? Yeah, Morgan.
well, it's sorted on the worksheet, but like, if you take one and then like 24 maybe, and how do you had this on our homework, how do you find like the derivative of the asks for like with respect to t?
Oh, there's no T. No T on your test. That's all starting on Monday.
Okay, so we don't have to worry about it being like with respect to t, like, okay.
No, it's all on Monday.
Could we do 25?
Sure.
And 22.
Oh, and 22? Okay, let's do 22 first and then we'll do 25. Alright, so we want to find the equation of the line that is tangent to this curve and perpendicular to this line, right? This is a tricky one. This is way hard. There are tangent lines on your test, no joke. But there's nothing this over the top complicated. This is pretty complicated. Because you have to like think. You have to think like 3 times on this one. You know what I'm saying? Like so yeah, it's a lot of thinking. So most problems you just have to kind of think once and then you kind of go from there with just math, but this one you have to actually think several times. So first thing we have to think about is, well, the line that's tangent to that curve is perpendicular to this line. So the first thing I know is I need to find the slope of this line, right? So I go 3y equals negative 2x plus 3, so y is negative 2/3 x plus y. So the slope of this line is negative 2/3, but I want to be perpendicular to this. So the perpendicular slope is positive 3/2. Okay? So now I'm looking for a tangent line. Remember, what 2 things do I need for a tangent line?
Point and slope.
A point and a slope. So I have my slope. my slope is 3/2. There's no going around that. Slope is 3/2. Now I need the point. This is trickier. I have to find the point on that curve where the slope is 3/2. So how do I find the slope of a tangent on this curve?
You equate it to the, like you equate.
3/2 is not an x value, guys. 3/2 is a slope. You can't plug in 3/2.
But you can equate the
Find the derivative, and I figure out where is the derivative equal to 3/2, and that'll give me my x value. So my y prime is 1/2 times 3x minus 1 to the negative 1/2 times 3. So bottom, bottom, top, 3 over 2 root 3x minus 1. All right, I want to know where this equals 3/2. So to solve this equation, you just cross multiply. So you get root 3x minus 1 equals 1. You square both sides, you get 3x minus 1 equals 1. 3x equals 2. X is 2/3. Now, that's part of my point. I still need a y value. Where do I find the y value? Plug it into where? The original function, not that line. That line may not even, this line isn't even probably tangent to this curve. It's just the line that's perpendicular to the tangent to that curve, right? So we need to plug into this function in order to get our y value. So you end up with the square root of 2 minus 1, which is the square root of 1, which is 1. So my point is 2/3 1. My slope is 3/2, and my equation is y minus 1 equals 3/2 times x minus 2/3, and I'm done. That was a toughie. Okay, there's a lot of thinking on that one. Here's what I do. When I want to give you a real tough kind of a problem like this, what I usually do is I break it down. So I'll say, like, for part A, determine the slope of the line that's perpendicular to this, right? And then I'll say, like, for part B, find y prime, right? And then for part C, I would say determine where y prime is equal to the slope that you found in part A, or something like that. I'll help you, and the College Board does that too. They like to kind of walk you through, not always, but often, they will help lead you to the answer by breaking it into parts. So, anyway, so that was that one. Are there any questions on that? I know it was tricky. It's hard when you get handed BAM and you're like, I don't know, right? But you know you could get partial credit. Even if you're totally lost, what could you do even if you're completely lost? You can always, when in doubt, take a derivative, right? Okay, so you know you'll get points if you find the derivative. Because somewhere in there it's going to be, the test is derivatives, right? So it's a pretty good shot, right? And then, of course, perpendicular to this line, so finding the perpendicular slope might be a smart thing to do, right? So that alone, say it was an 8-point problem, you're probably getting at least 2 or 3 points for this and at least 1 or 2 points for that right there, right? So, anyway. I mean, I prefer, obviously, you can solve it start to finish, but I don't want you to read it and just blank out and leave it blank, right? Always do something to attempt to get as many points as you can possibly get out of every problem. All right, one more. This is an implicit. So 25, someone asked for, right?
25.
Yeah.
Okay, and then I might call it on this worksheet, because I want to make sure we get through a few other things. Okay, I personally, again, would rewrite this problem. Yeah, there we go. I don't think it's cheating to just make the problem easier for yourself, right? So personally, what I would do is multiply this x plus 3y over here and just rewrite my problem as x to the 4th plus 3xy equals x minus 3y. right? Hey, look, I have no product, no quotient, right? It's so much easier. Well, actually, there is a little product, but that's okay. Yes.
Would that be,
Alright, what are
three
your
x to the third y? We should multiply 3y.
Oh, thank you, yes. There. Thank you very much. All right, good. So everything else okay? All right, good. All right, so now we have to differentiate this thing implicitly. Everyone take a second, and I want you guys to write the whole first line of this derivative. Implicit is big on your test, so make sure you can do this. Everyone do it. The battery is dying. Let's see if I can record. Let's see if this will reach. I just gotta make sure I don't trip on this while we're walking around. Ooh, it's gonna be close. You know, I think I might have an extension cord in my closet. There we go. That works. Oh, there's one. It's not pretty, but it'll work. All right, everyone have the first line or no? Need one more minute? You have it.
Would you use chain rule for the 3x third y?
Not chain roll,
Just product rule?
product roll.
Oh, okay, I got it. That's the only one.
There we go.
I didn't mean to do that.
That's better. And I need one more minute. We good? Here we go. What's the derivative of the first term? 4x cubed, right? All right, what rule do we have to use for this term? Product rule. So I'm going to think of it as like that times that. So the derivative of 3x cubed, well, that's, let's see, 9x squared y plus 3x cubed dy dx.
Why is the first y not y?
Very good question. All right, and this is what's so important in understanding when you do implicit is when you only put a dy dx when you're taking a derivative of a y. So in this first term, we are taking the derivative of the 3x cubed, but you're just multiplying by the second term. You weren't differentiating it. So you only put the dy dx when you're actually differentiating a y. Do you understand that? Okay. All right, equals 1 minus 3 dy dx. How'd you guys do? Fantastic. Okay, good. If we had to solve this for dy dx, you'd have to get all the dy dx terms on one side. And then move everything else to the other side. Factor out the dy dx. And I'm going to skip a step again and just divide. Okay, so that's sitting well with you? Okay. Good. All right, I want to show you an additional review that I put on my website yesterday afternoon. Okay, so, and I will put this recording on the website too. So this is now review worksheet number 3 is up there. This is the worksheet that Mr. Yang put up yesterday. And it's a good one. There's good stuff in here. So there's a couple things I want to make sure we touch on. The first one is this first problem, average and instantaneous rate of change. I want you guys to take 2 minutes right now and figure and do problems 1 and 2. And you can talk to each other, right? Work together. But take 2 minutes and do problems 1 and 2. Make sure this shows up. Say to the camera. We just don't want to. Okay, does anyone need another minute? Okay, well, I will walk you through. All right, average rate of change, that's just old-fashioned slope, right? That's just change in y over change in x. So our average rate of change would be f of 3 minus f of 1 over 3 minus 1. All right, so f of 3, well that's 12 minus 9, it's 3. F of 1 is 4 minus 1, it's 3 over 2. Our average rate of change is 0. Yeah, because average rate of change is just old-fashioned slope of the secant. It's just literally, like, whenever you have a function, this one is some sort of an upside-down parabola, right? So you have, what they're doing is they've got like a point here and a point here, and they're saying, what's that slope? So you're just finding the old-fashioned slope, changing y or changing x. Instantaneous rate of change is what?
Just one specific point.
It's the slope at one point, and how do we find that?
By using the derivative.
Derivative, right? So we need f prime of x. What's f prime of x?
4 minus 2x.
4 minus 2x. So, and they said at the end point, so f prime of 1 would be 4 minus 2 or 2. F prime of 3 would be 4 minus 6 or negative 2. Does that make sense? Okay, so average rate of change is just old-fashioned slope, change in y, change in x. Instantaneous rate of change, that's where you need the derivative, right? They're easy problems as long as you know what to do. Yeah, Jen.
For that number 3, would you find the derivative first and then find the derivative of that because it's like the y prime?
Oh, we're doing this down here, this one? Yes. For this one, it's the derivative of the derivative.
So you have to find the first one.
You'd have to find the first one and then find the second one. We might come back to this. I don't want to do this just yet because we've already done a million radical derivatives today. But if there's time, I definitely want to do a couple other things first, and then if there's time, we'll go back to that one. All right, so, okay, let's see, I'm skipping that one. Oh, this is a good one. Oh, I don't have it frozen, it's frozen. There we go. Dun dun dun. Okay. For a function to be differentiable, the first requirement is that the function has to be what?
Continuous.
Continuous. I want everyone, before anything else, to write what you would need to write so that this function is continuous. what would you need to start checking?
Limit.
Limits. And since it's a piecewise like this, you'd have to do a limit from the left and a limit from the right. Go ahead and do those. And see what that yields.
We're gonna do something like this in the test.
I don't know.
Yes. Yeah, that's true. I'll put a star by it.
Yeah.
There might be a star by the problem similar to this from your homework. Oh.
So like straight up.
Yeah, there's several of these in your homework, right? Okay, did you get those for your limits?
Yeah.
Okay. Remember when you're doing limits as x approaches 3, you have to actually plug the 3 in, right? So I had a lot of people on their last test when this problem occurred who wrote out the limit as x approaches 3 from the left and just put ax cubed. And you got to put the 3 in, right? So from this, what do we know? They have to equal each other. So 27a has to equal 9 plus b, right? Good. Does that give us the numbers?
No.
No. All right, so let's see what else we can glean. The function has to be differentiable. Whenever you need to see if something is differentiable, a good thing to start would be to find the derivative. So I want everyone to take a second and find f prime. It's a piecewise function, it'll be a piecewise derivative. What's the derivative of the top? 3ax squared. Very good. What's the derivative of the bottom?
2x plus b.
What is b? We know it's a constant, so the derivative is 0, right? Yes?
Why for ax cubed, why wouldn't you use the product rule?
Because a is a constant.
Because a is a constant, okay.
Yep. Technically it's a coefficient, but it's a number. Okay, so there's your derivatives. Now, for the function to be differentiable at x equals 3, that means that the slope going into 3 has to equal the slope coming out of 3. I'm going to step in here so I do this. Because if the slopes don't equal, what do you get? You get a sharp turn, right? So what we have to do for this, it's almost like saying f prime of 3 from the left has to equal f prime of 3 from the right. So we plug in a 3 to the left-hand side, and what do we get? 27a has to equal 6. So we've got A, right? Can we find B?
Yeah.
Do some substitution. 27 times 6 over 27 equals 9 plus B. So you get, bam, 6 is 9 plus B, and B is negative 3.
Wow, we're amazing.
You are amazing. That is very true. That is very true. All right, so 2 things when you're approaching a problem like this, if, say, you had to approach a problem like this. First, you check for continuity, do your limits, right? And then always find the derivative and check that the derivative from the left and right equal each other, right? So the limits have to equal each other and the derivatives have to equal each other. All right? Yes, Ram?
Are there general definition problems on this thing?
There are. And there are on this worksheet as well. But before we get into definition of derivative, let's do a tiny bit of PVA. Because there are problems in here we have not talked about yet. We've talked about them, but we haven't practiced them. So I want to make sure we go through this. For time's sake, I'm going to walk you through this one. And then when this is done, we'll do a little definition of derivative. Okay, so here's what we have. Let's see if I can zoom. Whoop. There. Okay. Okay, so we have a position function 2/3 t cubed minus 2t squared minus 1 for t greater than or equal to 0. So make sure you note that restriction, right? All right, first question, when is the particle moving to the left? What determines direction? Velocity. So everyone find a velocity function. It's okay. You can say it out loud. That's good.
No, don't.
Say it out loud. I'm not talking.
All right. So that is, let's see, 2t squared minus 4t, right? And then just to make my life a little easier, I'm going to go ahead and factor this. This is 2t times t minus 2. All right, I want to know when this particle is moving to the left. I'm going to have to make a sign line. When you have to make a sign line and you have a restriction like t has to be greater than 0, it's always a safe bet to cut the sign line off at 0 so you don't accidentally put negative stuff in there, right? All right, so all we have to do is find these two intervals. If t is 1, we get a negative. If t is 10, we get a positive. We are moving to the left on the interval from 0 to 2. And I'm going to write y because our velocity is negative. I'm going to put y's for most of these just so that you know why. Plus, I might ask you why tomorrow.
This is fun.
Yeah.
So if you're writing left on, or like it's decreasing, I don't know, the closed bracket, is there a closed bracket or an open bracket?
That's a very good question. For intervals of increasing, decreasing, or direction, the College Board doesn't care if you do a closed or an open bracket. But what you can't do, which some of you did on your last quiz, was you can't say like it's moving to the left on 0 to 2, and then say it's moving to the right on 2 to infinity, because you just said it's moving both left and right at 2, right? So you can't have it both. Since they don't care, your best bet is to always just keep all of those intervals open, because then you'll never make the mistake and get it wrong.
So it doesn't matter if there's like a closed bracket or an open bracket?
Not
around
for
0?
these, not for these. Technically, you could include the 0, and that would probably be more correct. Well, actually, technically at 0, it's not moving, it's at rest, right? So, yeah, I would probably not include 0 just because of that. All right, how do I know when velocity is increasing? When it's positive?
When acceleration is
When acceleration is positive. Oh no, I need acceleration.
Oh no, just give up.
Derivative of this.
Oh no, just give up.
Just give up.
Derivative of velocity, I'm going to use this velocity function because it's easier. So what's the derivative of velocity? 4t minus 4, or 4 times t minus 1. Alright, so I want to know when the acceleration is positive, so I make a quick acceleration sign line. And my acceleration is positive over here and negative in here. So velocity is increasing on 1 to infinity because the acceleration is positive there. Does that make sense? Velocity is increasing when acceleration is positive. Acceleration is the slope of velocity, so if it's positive, it's got positive slope, it's going up. Speed. When is the speed decreasing? How do I know when speed is decreasing?
When there's different signs. Velocity and acceleration.
That was lovely. Yes. When velocity and acceleration have opposite signs, right? So if I line up my velocity and my acceleration sign lines, all right, so here's what's going on. From 0 to 1, they're both negative, and from 2 on, they're both positive. So from 1 to 2, the acceleration is positive and the velocity is negative. So the speed is decreasing on the interval from 1 to 2 because A of t and V of t have opposite signs. And just, that's all you have to say. You don't have to say which one is what. Just say they have opposite signs, and that's good enough. Because sometimes if you volunteer too much information, you can accidentally mix them up and then you lose the point. So give enough information to answer the problem, but not too much to where you might mess it up. All right. Where is the particle located when the velocity is 0? Well, when is the velocity 0? We found it in part A.
0 and 2.
At 0 and 2. So we want to know where it's located, so we're just finding S of 0 and S of 2. All right, to save time, I just quickly used my calculator on this one.
Cheater.
I am a cheater. Okay, so S of 0 obviously is -1. S of 2 is -11 thirds. We want the particle's displacement from 0 to 3. This is the one I wanted to really talk about, this and this. Displacement is just how far you ended from how far you started. And so the way you find it is you just do the position at 3 minus the position at 0. That's it. Ending position minus starting position. So I'm going to tell you that your position at 3 is -1. Your position at 0 is -1, which means you are right back where you started and your displacement is 0.
What equation do you use for that?
It's just the position at the end minus the position at the beginning. You subtract the positions.
Okay, so it's 3 minutes.
So it's -1 minus -1. You got to find the positions at each of those spots. Okay, do you understand displacement?
Yeah.
All right. If I end at 10 and I started at 2, I'd have a displacement of 8, right? Does that make sense? Okay. All right. Distance is harder. When you find distance, you have to find the position at the endpoints, and you also have to find the position at any spot in between where you happen to have changed direction. What I like to do for this is I like to kind of make myself a little diagram. You don't have to. Technically, you're doing this minus this, absolute value, plus this minus this, absolute value. But here's what I like to do. I like to make a diagram. I like to say, all right, I started my S of 0, I started at -1, and then I went to -11 thirds. Then, that was at S of 2. Then, from there, I turned around